Area 51 technology, jet engines that bend time. Chapter 1. The Resonant Engine. You lie beside the silent hangar, tracing steel ribs that cradle the dormant turbine. The metal heart around you seems to hum in slumber, as turbine blades would spin at thousands of rotations per minute when ignited. You feel the potential of compressed air waiting to unfurl, a quiet reservoir of kinetic energy awaiting release. The hangar becomes a resonant chamber. Each exhale sends pressure waves that ripple along the girders like low-frequency ocean tides. Resonance amplifies specific frequencies when the structure matches their natural vibration. You sense how a metal shell can magnify a whisper into a gentle roar, a clear fact in acoustic physics guiding your steady breath. Soft pulses reveal hidden harmonics that dance beneath the hum. In sound science, every complex tone can be decomposed into simple sine waves, a principle you know as Fourier analysis. You imagine each blade stroke as a single waveform, building layered patterns that compose a symphony of mechanical motion, offering clarity in the language of vibration. Memories of speed fold softly, like waves bending around a rock. You consider Doppler effects, where motion shifts pitch and wavelength. The engine's turning mass once raced through airflow, altering its frequency for each observer. Now still, it holds an echo of that journey, reminding you that movement and sound are inseparable companions in physics and perception. In the hush, you feel a subtle thread reaching toward temporal harmonics, yet unseen. Harmonic overtones stack at integer multiples of a fundamental frequency, a gentle ladder of sound. You sense time itself vibrating in layered steps, like a hidden clock in every pulse. Science speaks in rhythms, and here you listen to its silent metronome. As the hangar's quiet resonance deepens, your awareness expands. You realize that every molecular motion, from air particles to metal atoms, contributes to this hum. The boundary between observer and observed softens, and curiosity stirs within your chest. What unseen frequencies lie beyond this shimmering threshold, ready to guide you further? Chapter 2. Temporal Harmonics. Night unfolding around you, you notice faint ripples drifting through the air, oscillations that carry a shift in pressure. These waves, like gentle breaths of sound or light, follow patterns described by frequency and wavelength. Each crest and trough obeys the fundamental rules of physics. The distance between peaks defines wavelength, and the speed at which they travel determines frequency. In this hush, you begin to trace their silent dance. As you study their course, the engine's steady pulse emerges, a metronomic heartbeat that syncs with minute fluctuations in time itself. Your awareness stretches along a continuum, sensing tiny shifts in duration that hint at time dilation, where moving frames alter the rate of passage. You feel the relationship between pulse period and relativistic effects, a reminder that time is not fixed. In the dim glow of your instruments, patterns appear as undulating lines, like glowing strands in a dark sea. You recognize a standing wave, formed when waves of matching frequency intersect and lock in place. These nodes and antinodes reveal regions of calm and intense motion, a clear demonstration of wave interference. With careful attention, You map these contours as though charting an unseen topography of energy. Each oscillation carries information about the medium through which it travels, from subtle air currents to magnetic fields. You compare amplitude variations, observing how higher peaks can signal greater energy transfer, just as spectral lines in light spectra reveal atomic compositions. In this space between sound and electromagnetism, you sense the hidden seams where different forces intertwine, a crossroad of natural laws waiting to be explored. You lean closer to the chronoturbine, a device tuned to resonate with temporal harmonics, hoping to hear its whisper. Inside its mechanism, tiny oscillators vibrate at distinct frequencies, each one modulating the flow of time in subtle increments. The turbine's design relies on resonance, where energy builds and channels into bursts of synchrony. As you await the next pulse, curiosity hangs in the air, gently inviting you deeper into the unfolding mystery. Chapter 3: Chronoturbine Whisper. You stand before the chronoturbine, its blades turning with calm precision. Your breath sinks with a soft murmur, like a gentle pulse of kinetic energy in motion. Each blade captures airflow and converts it into rotational force. In aerodynamics, that conversion follows Bernoulli principle, where pressure differences create lift and drive. You feel the quiet balance between wind and metal, a partnership that hums with subtle scientific grace. A metallic wind brushes your skin, a reminder of angular momentum swirling around each rim. Angular momentum is the measure of an object's rotation, conserved when no external torque acts. This invisible force suspends moments in flight, each rotation storing energy that could power lamps like beacons. You sense how physics can hold lasting seconds aloft, a quiet choreography of spin and gentle pause bound by Newton's elegant laws. You trace a blueprint of sound rippling through steel blades, each wave carrying tiny pressure changes. Sound travels through air at roughly 340 meters per second. You see how frequency keys the melody. Higher tones vibrate faster, lower ones slower. Echoes form corridors in stillness, channeling energy like gentle pulses. The turbine's hum becomes proof of acoustics at work, a quiet invitation to listen deeper into hidden patterns. In this fleeting melody, you softly witness how wave interference can amplify or cancel sounds. When two waves align in phase, they boost each other, and when opposed, they fade into silence. This principle of superposition reveals how intent can sculpt outcomes. Small alignments grow into resonant events. You imagine aligning your purpose with natural rhythms, nurturing echoes that unfold into tomorrow. The turbine's song hums with quiet promise. You inhale the metallic hum, feeling vibrations resonate within you. In engineering, a blueprint is a plan drawn to scale, detailing every measurement. Here, the blueprint of temporal sound hints at hidden schematics, like an unread diagram awaiting your touch. You see that each pattern suggests a path forward, and within this whisper lies a coded design. You lean closer, curiosity stirring as the wind carries the next secret. Chapter 4: The Suppressed Blueprint. You crouch beside a low table in twilight, watching a folded sheet of heavy paper etched with ancient iron flake pigments. Each crease holds whispers of pressure and time, like crystalline lattices in steel that form when iron cools below 912 degrees Celsius. You feel the paper's edge, fibers of cellulose aligned by human hands. You notice microfissures, where metal particles reflect a faint orange glow, reminding you that matter remembers its forging. You lift the corner to reveal ink that seems to seep into metal threads embedded in the parchment. This is iron gall ink, born from gallic acid and iron sulfate combining in medieval labs. You sense diffusion at work, molecules migrating through capillaries in tiny winding channels. The ink's acidity etches a microscopic record, preserving chemical reactions across centuries. You marvel at how a formula can both record and alter the very surface it inhabits. Tracing each curve of the blueprint, you see symmetrical diagrams suggesting gears and valves, modular designs that hint at automation before electric motors. You recall photolithography, where UV light etches patterns onto silicon wafers. This blueprint feels like its ancestor. The lines are precise, drawn with drafting compasses calibrated to millimeter scales. You imagine lenses focusing sunlight through glass rods, transforming raw light into the geometry of invention. In the hush, the past and future collide on this crisp map of possibility. The paper's cellulose chains carry tensile strength up to 200 megapascals when stretched, yet it bows under your gentle breath. You observe ink particles that form clusters reminiscent of nanoparticle agglomeration. Every mark becomes a node in a network of ideas, as electron clouds dance around atomic nuclei, binding atoms into structures yet to be realized. As you lean in, the sheet trembles with latent energy, an alchemy of material secrets waiting to be unlocked. From molecular bonds to macroscopic design, you sense a convergence of chemistry, physics, and human intention. The blueprint is more than lines on paper. It is a suppressed plan for a silent revolution in matter. Your fingertips hover above the ink as questions stir. What final transformation does this design demand? Chapter 5. Material Alchemy. You rest your fingers on a cool ingot, feeling a subtle hum beneath your touch. Within every alloy lies a hidden chronicle of celestial fire. Iron, nickel, copper, these elements forged in distant stars, carried here on cosmic winds. You sense how each atom bears a story of supernovae and neutron stars, softly vibrating with ancient energy. You gently warm the metal above a flame, observing its glow shift from dull red to molten gold. In the crucible, atoms break free, mixing and aligning in liquid symphony. You imagine phase diagrams mapping the transitions. Solid solution, eutectic mixtures, intermetallic compounds. This is real alchemy, governed not by magic, but by thermodynamics and the dance of entropy. As the molten blend cools, crystals begin to take shape. You glimpse grain boundaries where tiny misalignments meet, like the seams of a vast tapestry. These interfaces guide strength and flexibility, determining how the metal bends or holds. With each controlled cooling rate, you craft microstructures. Perlite, martensite, bainite, each named for different cooling paths in steel metallurgy. Beneath your gaze, electrons roam freely through metallic bonds, creating a sea that conducts heat and current. You understand how band theory explains conductivity. A shared energy band allows electrons to flow like water through channels. Subtle impurities scatter electrons, and you see why semiconductors require precise doping, an artful balance of extra atoms within the crystal lattice. Every crystalline grain behaves like a corridor of potential, guiding waves of light or sound with precision. You marvel at photonic crystals etched into silicon, their periodic structure bending photons like whispering walls. In alloys, phase-separated domains form natural metamaterials, each microscopic region resonating at its own frequency. This delicate architecture turns simple metals into conduits of hidden energy. In that gentle glow of forging, you feel the slow pulse of metals that once drank from the river of time. Each grain holds promise, latent corridors where quantum vibrations hum beneath the surface. You sense the next layer emerging, quantum lubricants gliding between atomic planes, softening friction like dew on petals. You imagine atomic vibrations dancing, opening secret passages to smoother motion ever so gently, truly. Chapter 6. Quantum Lubricants. You stand in the quiet hum of the laboratory, where gentle lights reflect on polished glass. In your hand, you hold a tiny droplet of lubricant fluid, its surface shimmering like moons on a dark ocean. Each droplet feels weightless against the backdrop of the stainless steel bench. You lean closer, watching molecules align at the edge, drawing patterns no larger than a billionth of a meter. In this stillness, you sense the promise of slipping friction into silence. You learn that lubrication at the atomic scale relies on van der Waals forces, a gentle attraction between molecules. These interactions allow layers of fluid to slide, reducing wear in moving parts. In research, scientists engineer fluids with additives to form monolayers a few nanometers thick. This layer acts like a velvety carpet, distributing pressure evenly across surfaces. A tiny change in molecular structure can shift friction coefficients, revealing the balance of contact and movement. In the realm of quantum lubricants, particles dance with an elegance born from uncertainty. You imagine electrons tunneling through energy barriers, letting surfaces glide without direct contact. Quantum tunneling is a real phenomenon where particles traverse gaps smaller than their classical wavelength, reminding you that at tiny scales, our rules of friction bend. Researchers explore superlubricity by aligning crystal lattices. When planes match, resistance drops and motion feels almost silent. You watch droplets slip into the meshed gears of a nanodevice, each bead reflecting vibrational modes like distant chimes. Inside, Brownian motion stirs molecules in perpetual dance, a jitter that keeps the system alive. Brownian motion is the random movement of particles in fluid, driven by collisions with surrounding molecules. This restless energy, set by temperature, prevents surfaces from locking and keeps movement smooth. Each microscopic droplet holds a universe folded within its molecular structure, a cosmos where forces whisper possibilities. As you hold it near your eye, light refracts through the curved surface, splitting into colors mere angstroms wide. You sense momentum echoing through the liquid, an invitation to explore unseen forces and subtle resonances. You breathe softly, feeling its warmth gently. The droplet cradles motion and stillness, a gentle prompt for the journey you continue. Chapter 7. The Echo of Momentum. You rest in the quiet hum of night, your breath a gentle drum. In the hush, you sense a memory of motion, an echo from wings or engines long stilled. This reverberation feels like a soft exhalation of physics, an imprint of forces once in flight. Each pulse hints at momentum, a product of mass and velocity entwined in space. You draw your attention to the principle that momentum equals mass multiplied by velocity. This simple equation, P equals mv, traces a straight path through complex skies, When you imagine a heavy cargo plane cruising steadily, its large mass and constant speed combine to carry significant momentum. Even a slight change in velocity demands a precise thrust, a reminder of balance in motion. In the darkness, you feel a slow vibration echoing around you, like sound waves reflecting inside a cavern. These pressure oscillations follow patterns, just as standing waves form at specific frequencies. Your awareness of frequency invites curiosity about resonance. In metal wings, tiny vibrations can amplify or cancel each other, illustrating how systems seek harmony or divergence in flight. Your mind drifts to air currents shaping fractal patterns around a wingtip. This self-similarity appears in swirling eddies of different sizes, a cascade of energy from large to small scales. Scientists call this turbulence, a dance of chaos and order. In each swirl you discover a hidden loop, echoing momentum in a timeless spiral. The soft vibrations you sense resonate beyond steel and air. They fold into time, as if past and present motion share a secret rhythm. When you slow your breath, you align with that silent cadence. Each exhale feels like a release of stored energy, each inhale like capturing a gentle thrust. In this stillness, you become one with the echo. You sense a promise in the lingering vibration, a bridge into deeper layers of flight. Soon, you will explore how lift and pressure interplay in the silent craft of wings. You carry this echo in your mind, a gentle trace of movement waiting to unfold. Let the momentum of discovery drift you closer to understanding aerodynamics as you drift toward the next horizon. Let curiosity carry forward into whispered air currents. Chapter 8: Folded Aerodynamics. You stand beneath an open sky, where wind drifts like soft silk, folding invisible layers around you. In this gentle caress, you sense the air behaving as a fluid, negotiating pressure and velocity in a quiet ballet. Each current you feel carries subtle gradients of speed, shaping unseen contours as it brushes past. The atmosphere becomes a canvas of motion, and you watch how gentle shifts in density translate into the patterns that guide every soaring vessel. Your attention drifts to a wing's edge, where shape meets airflow. You trace how a curved surface generates lift by creating pressure differences above and below the wing. This principle, rooted in Bernoulli's discovery, ensures that air moves faster over the convex top, lowering pressure and granting upward force. Even a slight change in curvature or angle of attack shifts the balance, guiding a craft along gentle arcs across the sky. At the wing's tip, small winglets curb swirling vortices that might steal energy, blending science and design. You imagine engineers in sunlit hangars unrolling prototypes like parchment maps of air. Their wind tunnels hum with purpose, unveiling how folded surfaces can channel airflow along curved trails. In desert sands, they test models with subtle corrugations, refining patterns that reduce drag. You learn that the slightest ridge or fold guides vortices in predictable loops, revealing a secret dialogue between form and flow. Smoke trails or tufts of yarn highlight the invisible paths, mapping the currents like calligraphy. In your mind, a futuristic wing morphs its shape in response to sensors that measure pressure in real time. Tiny actuators adjust folds and ridges, guiding lift and roll with fluid precision. This feedback loop, inspired by birds adjusting primary feathers mid-flight, promises greater efficiency and stability. You sense that aerodynamics is not static, but a living conversation between structure and atmosphere, ever adapting to unseen currents. As you breathe in that image, you feel the promise of discovery fold into your curiosity. These hidden feedback loops whisper of instruments and eyes unturned, a secret waiting beyond the horizon of knowledge. In the hush between gusts, you sense a balance, ready to unfold in the next moment. Chapter 9. Unseen Feedback. You stand in a dim control room where panels of lights pulse gently like breathing stars. You observe the glow of circuits, each LED reflecting a tiny decision in an electronic brain. Feedback loops here are the quiet regulators of any engineered system. They compare output with a desired value, then adjust signals to keep the whole engine balanced and true. Always. You notice a soft hiss of data pulses traveling along copper veins. Each pulse is a binary whisper, a 1 or 0 encoded as a brief voltage change. In digital electronics, these sequences carry every image, word, and map you send. The transitions occur in nanoseconds, too fast for the ear, yet they shape each second of modern life with invisible precision. Beneath the hum, you perceive echoes of past inputs recorded in memory buffers. These buffers store information temporarily before the processor decides its fate. Their fleeting contents trace patterns of behavior like footprints in sand. Governments once seeded hidden directives in these circuits, hoping data would vanish. But the ghost signals persisted, revealing truth that refused to stay completely buried in darkness. You follow each circuit path in your mind as if tracing a river's winding course. Information flows through channels of copper and silicon at speeds approaching 2/3 the rate of light, slowed by resistance and heat. You imagine electrons as curious travelers, colliding and scattering, yet always moving forward. This journey sculpted every calculation and every message sent across this engineered network. Within this steel shell, signals loop back to their origins in silent dialogues. Control theory teaches that feedback is essential. Sensors measure temperature, speed, or position. Then controllers tweak inputs to avoid instability. You sense these exchanges like distant whispers, each correction nudging the entire system toward harmony. The precision is a testament to human curiosity and the elegance of remarkable design. As you lean closer, the hum grows richer, and you realize a greater question stirs beyond the control room. How does information shape our understanding of reality? In physics, entropy measures how systems evolve from order to disorder over time. You feel the pull of uncertainty and possibility, like a tide of inquiry gently inviting you onward, promising discoveries beyond tonight's horizon. Chapter 10. Beyond the Gate. You stand before an archway of humming metal, its surface shimmering in low light. Each beam resonates at a precise frequency, like a tuning fork waiting for the perfect note. You feel the subtle vibration in the air, a tangible echo of energy moving through solid steel. In physics, resonance describes how objects oscillate in harmony when matched to their natural frequency. And here you sense that harmony deep in your bones. Soft beams of light dance along curved edges, revealing patterns like ripples on a still pond. Light behaves as both a particle and a wave, and that duality breathes life into these glowing bars. You trace subtle interference fringes where waves overlap, and create bands of brightness and shadow. This gentle play of photons reminds you that nature often balances contradictions to form something unexpected and beautiful. In this quiet moment, you recognize the legacy of forbidden science embedded in the structure before you. Quantum states can exist in superposition, occupying multiple possibilities until observed. Here, each beam carries whispers of parallel realities, folded like pages in a book you have barely begun to read. You feel curiosity awaken as you consider how observation shapes outcome, how your own gaze might collapse endless potential into a single bright path. You sense the culmination of experiments that once defied convention, now standing here as a portal to the unknown. The arch's geometry hints at a tesseract, a four-dimensional cube whose faces you cannot hold in your mind, but whose outline you almost perceive. In topology, complex shapes reveal hidden connections, and here you glimpse threads that weave distant points together. The gate invites you to lean forward, to trust what your senses lightly touch. In the hush, time itself seems to pause as you press a tentative step toward the threshold. According to Einstein's insight, time and space intertwine, stretching and contracting around mass and motion like a flexible fabric. You feel each second lingering, heartbeat and breath synchronized with the arch's silent pulse. Ahead, space may unfurl in dimensions you cannot yet imagine. Beckoning with gentle promise, you remain poised between what is known and what waits, carrying the echo of discovery as a soft, quiet invitation to step through beyond the gate.